Very much and good morning. Welcome you all and welcome to this panel that we're going to present about information, geospatial information in the cloud. We are accompanied by three excellent speakers for our session. We have Bernardo Pizarro, who is going to present geospatial information of the Canaries on the cloud, and we also have Alfonso Dávila from CIGMA that is going to present geospatial information on cloud. And our third speaker will talk about Catastro, and he is Francisco Garrido. I'm going to make a very brief summary of their CVs. They're great speakers. We have known them for a while, but in order to save some time, our main challenge in this session is time. We just have 1 hour for the three of them. So I will ask you to please, if you want questions, please write them down, put your name and your email, so that if at the end of the presentation we don't have time to answer them, our speakers will later on answer them. I thank you for your presence, and once again I will start with the presentation of Bernardo Pizarro, who is the first presentation that we had. He's the Managing Director of the Cartografías Canarias, Geodata SA as a regional manager, and some of his main positions, the government in the Canaries, information manager, chief of cartography department in Canarias, and he has participated in national and international events, both in Mexico and Colombia, Peru, and other countries. As for Alfonso Dávila, he's an industrial engineer. He also has an MA in CIGMA by the University of California. He has over 20 years of experience, and her main strength is this creation of geographic information systems, and he is the Director of Strategic Development for CIGMA, a company that many of us know. And finally, Francisco Trinidad is a geologist with an MA in science by the Roosevelt Foundation, and he has acquired his proficiency as computing applied to engineering in important institution in Mexico. He has participated in multiple projects in Mexico, Guanajuato, Tlaxcala, Mérida, and other states as a consultant in the World Bank for the project of the World Bank in Colima and the national registration. I'm going to, something he has done is implement and design Geospace Desktop, which is integrating land registry application on cloud application. In a very simple, summarized fashion, I would like to welcome our speakers, and I would like to start with Bernardo Pizarro. Thank you. First of all, I would like to thank you for organizing this event, for inviting me to this Congress. I have the opportunity to attend some of the presentations, and I have had a quite positive impression of the quality, the high technical levels that we have witnessed. And secondly, I would like to congratulate you for this. Considering the time that we have, that is not much. I thought that I was going to have 25 minutes, but then I will summarize this in 10. I'm going to present my geospatial information on the cloud. First, I represent GraphCan, that is the graphic institute in the Canaries, and the objective is to guarantee availability of information, quality, organization, and accessibility to that information. We comply with quality standards ISO and UNA, and we have been providing services for public administrations for over 20 years. For the last 20 years, the purpose that we had been set by the government was to become an instrument meant to provide public services to both canneries and professional and private entities. I think probably I shouldn't say so, that we have created a global framework that is reference worldwide that allows us to have information of the territory of the canneries that is accurate, updated, and reliable. Considering our link with the territorial space of Canarias, our main purpose with information we produce is planning and land management. We include data, metadata, hardware and software, and infrastructure. We provide then complete, harmonized information, accurate and high quality. This information system in the Canaries is a system that gathers in one same institution all the components, not only of territorial information, but of the services that we provide, and we contribute to a rationalization of public expense, avoiding different actors or parties or administrators to be tempted to provide or get territorial information from their own sources. Therefore, we make public administration information more efficient. We have recently had the chance to, or we have recently realized that we have to be innovators in everything that has to do with land information, which is in the creation of the cartographies and the different products related to this, and also for the services that we provide. Our activity complies with this. This is, we're following the SPIDE guideline. We have followed them since 2007, and this establishes some recommendations and a group of data and services that should be available and that should be offered by the citizens of the European Union. So what was this necessary to create standards, the INSPIRE standard in Europe, to address problems that we have with handling information with different administrations without having control of that. Information was not available for all the users that required it, and also to establish some mechanisms to solve the problem through the creation of interoperability standards for space data and for all the different models we have behind it. We have coordinate and different types of information that are shared. This establishes the minimum groups that should be available for all citizens. So that's like the introduction. We're a public instrument for information administration in the Canaries in order to gather geographic and geospatial information. Now I go to the core of my presentation, the cloud. I think this session is entitled Geospatial Information in the Cloud. What's the cloud? First of all, I think I got the definition of the Wikipedia. I don't think I can find it in a dictionary. It probably would describe something different. The cloud, according to Wikipedia, is a service that is provided through the internet without the need to have something locally installed. I think we all understand that that's the cloud. So what's the main feature of this cloud? Well, it gives you independency from the access platform, both for hardware and operative systems. Now we will see what problems emerged when we didn't have solutions that because everything depended on the platform. Another thing that we've seen, it gives us a geo distribution. Data can be more than one and geographically scattered in different locations. And in my point of view, something else that the cloud must have is should measure the architectures that provide service through the cloud, which should grow in a dynamic way. I mean, they should be scalable in order to cover the service demand that may be present and changing. So I'm going to make a retrospective of the last 15 years. I know that we've talked about what we are going to see in 15 years, but we shouldn't forget what we have seen. The cloud, the concept of the cloud has presented the solution to one of our greatest challenges as a geographic institute. We are an instrument to produce information, but on the other hand, to offer that information to our users. There's no use in having topographic maps or having good quality geographic information if in the end we will not have this available for those who may require it. I think that yesterday I heard something about this in one of the keynote lectures that we heard yesterday. Dr. Soho had given some instruction of new businesses in cartography and the use of them, of those products. So I think one of the greatest challenges that we had as an institution was to make sure that this information would be usable. The concept of the cloud and everything behind it has presented a great solution to many challenges. So I will explain why and what is it and why. In 1995, when I started working in this institution, what we did to spread information among our users was through local installation. You had to go through each municipality with each administrator and perform a local installation of software and data. The operative system or the hard drive, making sure that we had enough memory, the processor, that if it was compatible with the application, everything was a problem. It was really difficult. Even though you have an appropriate software solution, you would depend on the environment that you had. You would apply it to use a server, and administration was local, was expensive, and was complex. You required some staff dedicated to that, the administration of such applications. In the 2003, we changed the architecture to a centralized distribution. It was the same application, but distributed through some terminals. The same centralized data was no longer loaded locally, but they had a centralized server, but the administration was centralized and not localized. And then in 2008, we changed to the cloud. These are more independent programs that have access through a browser to all the functionality with technology that is mainly working through browsers. As I said, everything is centralized. I mean, there's no centralization. Everything is distributed through the different countries. And the characteristic that this architecture presented was that it allowed us to have this universal access to information, and we will see this in detail. In 2003, how was this distribution? Through Citrix. We now have other technologies, but Citrix is a software, and we would have a map that was the software developed under this toolbox. Final user would get connected to a centralized server where the application was located, and through the server there was an execution of everything. And Citrix had two servers centralized in two data centers physically in order to guarantee that there was a backup. And users were mostly technicians in public administration. That was the architecture that we had back then. data. We had about 1,500 users in the Canaries. Well, it's a small region in Spain that has 2 million inhabitants and 7,500 square kilometers. We had then 1,500 installations. The number of sessions that had been open in that time had their peak in 2008 and 09 to 234,000 visits, sessions that were open through this technology. The middle cost or average cost was 14.67 euros per session, and this presents a contrast and in the way that they are accounted for. Then in 08 we changed it, first because of Inspire standard that would recommend universal access to information, free access information, and back then in Spain we were also defending that everything should be free and available to everyone. Then the number of users was multiplied, and we will see how this number has grown. We designed a robust system, 360 days available, 24 hours a day, fast response, 0.2 seconds as a response time. It should be safe and with universal access. As I said, this architecture was designed by engineers. We still have 3 nodes, one in Tenerife, one in Las Palmas, and one in Ireland. And it provides services to all of those. In 08 that we started to work with this, we have not had any shutdowns in the systems. Users have always had access to the information, and well, we have all the different categories. You can see the visits. It is an IDE architecture that we all know. We have over 200 billion queries, and we have around 4,000 users connected every day. And the client, there's no unique client. We have a visitor. We have the RView, we have all the different users. They're all clients of this architectures. Average cost, in this case, is 1.58 euros. We have reduced it by 14 euros. We have multiplied the number of users, so I think that we are providing public service in terms of access to information. We have the statistics. Since all of this is downloadable, I'm already seeing the yellow card, but I'm about to finish. In 08, in terms of statistics, we have seen a growing evolution, slow but evolving. The minimum 2 years ago, we had the maximum, which are now the minimum, and the response times are now 0.1 seconds. In my point of view, the key points for success in our case have been the cloud, mainly the cloud, this architecture, this system that provides information in a very easy way, which is fast, making information updated, accurate, despite regardless of the platform. And interoperability would be the second point. Systems are interconnected, which I think is the most important thing. This interoperability for me is the most important part that we have witnessed in the last years in our field. And the third point in our case, there will be no point in having a good system, a good architecture, if you don't have information. There will be no point if you don't have any information to provide. And in our case, the other key of success has been the content. We have worked on content, and in the end, that is the most expensive part of this puzzle. Well, architecture is becoming cheaper and cheaper, fortunately. So, well, these are the contents that we have available. We have photographic flights. We have 22 centimeters per pixel, 10 centimeters per pixel, and we have a coverage in all the territory. Auto picture, we have them every year at 10 centimeters in the urban systems. Topographic maps, we have invented a new concept. That is something we update every year in all the territory. The street uses theme maps that we do with the cooperation of the Institute Geological Spanish Institute with universities. Update frequency is not yearly, but we do some collaboration every 2 years with these institutions. Access systems, we have the visors that we provide with free access, but also have tools to download information, some for free, some that are paid. But this photo library service is accessible online, also with high resolution, with 14 micra resolution. LiDAR is also available. I haven't had a country in the world which has LiDAR real-time information. The point cloud with the coverage of all the territory. We also have detected some changes in the territory to control the urban disciplines and also to update cartography and the land registers. Download service, almost 427,000 files. When it was free, which was in 2010, I think, more than 50,000 files were downloaded. 500,000 files were downloaded back then. And well, I don't want to take more time. Thank you for your attention.
Go ahead, Alfonso. Good morning. Thank you for the panel, my colleagues. My name is Alfonso Dávila. I work at CIGMA, and I will be talking a little bit about how we manage geospatial information in the cloud. So at the event organized by INEGI in 2011, we had this internet movement all over the world. Almost 750 million emails were sent every day. There were 1.8 million queries online or searches and 500,000 tweets worldwide. That was in 2011 when we were talking about this issue or this topic a couple of years ago. Today, this has doubled. All of this has doubled. It's almost 144 billion emails per day. Over 300 million photographs are uploaded into Facebook. 327,000 tweets per minute. More than 1.3 billion smartphones all over the world, and 5.3 billion mobile phones all in the world. This change between 2011 and 2013 can give you an idea of the size of how the internet is evolving in all areas. In Mexico, 32% of households have access to a computer, and of those, 26% have internet connections. And curiously, there are almost 41 million people, Mexicans who use internet. Some do it at an internet cafe or a cyber cafe, some on their smartphone or their computer, but there are almost 40 million Mexicans who today use the internet. These numbers are influenced by the use of the cloud and cloud computing. As Bernardo was saying, there are an infinity of applications and institutions that run in the cloud today. And the cloud has certain features that are important for us to remember. One is its agility. The cloud enables me to take data, upload them, create an application, and make it available. It also enables me to have elasticity. If I have a user, the consumption that I pay for is for that user. If I have 100,000 users, then I pay for those 100,000. So there's an elasticity that allows the cloud to grow depending on my requirements. I can measure everything because the applications that are made for the cloud have to be able to measure all of the transactions, the download and upload times, latencies, etc. It's scalable, and it also enables self-service. These features that the cloud has are very appropriate for the new types of applications that are being created, both for mobile devices and for the web. What do I mean? Well, today you can take an application, develop it very quickly, put it on a server that's in the cloud, and as I was saying, publish it, post it. This also has its pros and cons. But there are three types of applications or of ways of using the cloud. The first is that I ask for computer capacity. I want servers that are this size with so much memory, and that's where I'm going to place my application. And so I rent that capacity. The second is that I can rent a platform that already includes the computer capacity, but also a whole series of technology that will enable me to develop whatever it is I want to put in the cloud. And the third is that I create a software that does something very specific, and I upload it and put it in the cloud. Now, the cloud, it's like saying everything, I just sort of put it up there. But in reality, there's a hybrid version that enables you to continue handling things locally and to be able to have certain capabilities in the cloud. It's not, everything is not local and not everything is in the cloud. The transition is occurring, and there's a hybrid issue that's coming up, and that I think the trends show that it will continue to be hybrid because of the type of information that is required that one has sometimes in the cloud and sometimes you need it locally. So based on these concepts, the geographic information systems have also been affected by these by this international trend that has to do with the internet development. This worldwide change in how the internet is used has led over the years to geographic information systems be able to operate also in the cloud. In the 70s, they used mini computers. In the 90s, they already used web servers. And now, from 2010 to now, the geographic information systems can operate in any one of these three classifications that I mentioned in the cloud. In our case, ArcGIS has become a platform that is based on the cloud. It's a cloud-based platform. As someone was saying yesterday, desktop users and many of you who are GIS professionals, you use a computer every day to process data, to convert them, to import them, to personalize them, to adjust them to the applications. And then you put them into servers. And what happens within this platform that we call WebGIS, which now has a cloud component? It's like having an extension. I continue working with my computer like I do every day, but now I have a user that enables me to connect to the cloud, and certain information that I have, I can put it there in a transparent way, and I can operate certain information in the cloud. I can use the capabilities of the cloud, and I can share all of the work that I did quickly and easily. So the ArcGIS platform has all of that integration with the cloud. But what is this concept of WebGIS that Jack Dingerman was explaining? It's a new way of managing content. It's a platform. And in that platform, I work as a GIS professional. I develop my content, and then I put it in the cloud so that it can be consulted or queried. But who's going to do that? Is the information going to be public? Not all of the information should be public. So organizations have to have a way of controlling who can see the information, who is authorized to see the information, who is a user, who are the ones who query that information or search that information, and who are the ones who are going to take that information, reprocess it, and generate it again as a new product. All of that, all of these features that you have on the WebGIS make it possible for areas to no longer have these barriers. I have a map, I make it available, and then another area, if it's authorized, can now use it. But it uses the access to the information. It doesn't take the data. If I don't authorize it, they cannot edit, they cannot modify it, they can't change the symbols, they can't do anything because the author of that information is me. On the other hand, it enables that information to be connected to different types of digital documents. It makes it possible to be able to superimpose all of the different maps, be it locally or what you have in the cloud. And the most important thing is that you can now broaden the spatial analysis capabilities in the cloud. That's part of this platform. And this platform that I'm talking about has the characteristic that will enable you to load all sorts of information. That information will reside in the cloud, or it can reside locally and then have the functionality of the cloud. And as I was saying, this capacity or capabilities that geographic systems have of operating in the cloud are what will enable the entire organization to be able to use the maps. In our experience here in Mexico, what we've seen is that users, traditional users of GIS system, the professionals, the specialists who use the technology, they find a faster way of delivering their products, of their requirements, and making it easier for other users to access who are not interested in how the map was created. What they're interested in is the map, to be able to load it into a PowerPoint, to be able to go in and pull that information into other applications. That's what they're interested in. And almost 60% of your organizations today, that's what they're interested in, who today do not use a map. And the cloud is a way out. The GIS in the cloud is a way out for this requirement, and especially because it ensures a new experience for them. I see a lot of well-known faces here that we probably had very long discussions as to how to do it so that other areas could use the information 10 years ago, and the only way is that they had to have a license, a user license for the software. And now all they have to do is connect to their iPhone, their iPod, their Android, that they go into a web page, as Bernardo was talking about. All of that ease, that new experience for users is what's going to allow you to manage information in the cloud. Now, in summary, in the cloud, in this ArcGIS platform that operates in the cloud, you can manage web maps. What is a web map? It's a map that contains a series of properties so that the user can use it very quickly. It's no longer a question of, okay, here's the link to the map and let's see what you do with it. No, that map already comes with an application so that I can double-click, open it, and move around it. It can have tools to change the symbology or the legends, and it's already contained in the map component. It has all of the tools for authentication and group generation and who can see it, who cannot see it, who can access it. Is it public? Is it a private map? Do I only want to share it with X or Y? The other part is going to ask me for the publication of the data. It will enable me to figure out costs. I'm going to have a vast amount of data online that other companies have put up and users have put up so that they can be used. And the most important thing is that I continue to be a specialized user. I work every day with these tools, and I can broaden my use towards the cloud and also integrate all of this to the institutional systems that you already have. Those of you who have SAP or Salesforce or Office, all of this concept, you can already integrate it with these sorts of applications. And then the important part is that the geographic information systems are going through a technological transition. You're going to find a lot of products being offered for using geographic systems in the cloud. But there are two points that I'd like to stress. The first is that because of the characteristics of the cloud, not everything can be in the cloud. Nor is it advisable for everything to remain as it is, because then you're not taking advantage of a technological evolution that's natural and that we're all immersed in. But what's interesting is that in the case of ArcGIS, there is so much knowledge and experience that has accumulated in the products that were developed by the company since it was started up, that it is a concept of migration towards the cloud. The knowledge, the experience, everything is already there. It's simply a question of leveraging the technological advances in the cloud so that we can add more components. If you can see, take a look at that slide, and the bottom of the slide, it's all of the desktop tools that exist, and all of the ones, the upper part are all of the tools that you can find on the platform today. There's for uploading, for analyzing, to be able to make buffers, all sorts of tools that are already available for you to use. But there are two important points in conclusion that I'd like to mention. The first has to do with security and data management when you want to work in the cloud. The first, there's a question of security that has to do with the technical part of it, whether they're encrypted, whether they're in a secure area, can I share them, etc. From a technical point of view, are they in the formats that they should be? The second has to do with intellectual property. A lot of the information that you generate and that is available online was yielded or ceded. The rights and the user rights were ceded when you click and you say I accept on the software license. That's what we call a rights exchange. I download the software, I do click, and I'm authorizing you to use all of the information that I may add into that application. And that has implications because not all of the information, the user using the tool has the authority to cede those rights, to transfer those rights. And then there's a legal question. There are different organizations worldwide or agencies or companies that offer services in the cloud. But this is like when you're going to buy a house. You can go with a developer or a builder that nobody knows or nobody's ever heard of and sign a contract and give 50% down, and you don't know what's going to happen. Or you can spend that same amount of money with a formal company that's established, that's recognized, that has a whole structure behind it to be able to guarantee and offer that service. And the other part is that those contracts, those service contracts in the cloud are not always, they do not always respond, or they're not always, they can't necessarily have to be complied with outside of the country's borders. They're designed to operate in the place where the servers and the farms are, but that doesn't extend to the users. And the other part is that the U.S. government has this Freedom of Information Act with which it can request any U.S. company any sort of information. So these are security schemes that we have to be aware of when we want to go into the cloud. And the second point is the data. Most of you here work with data. And because this cost, well, I can't have version 1, version 2, version 3, the one that my boss wants, the one that I sent, the one that he corrected, and put all that in the cloud because it all costs money. So it requires a lot of work to prepare the information which is going to be uploaded into the cloud, because the cloud is not a hard disk. It's a platform on which all of the transactions are measured, and they're all linked to a cost. That it's cheaper, yes, that's probably true, but it implies that you have to have the resources. And in conclusion, according to this study of the Business Software Alliance for this year, a study of 2013, this is the scorecard for cloud computing for many countries. Where you see the red arrow, you can see that's Mexico. The first part of this graph, which is in blue, represents the level of infrastructure development that Mexico has for broadband relative to other countries. Now, our country has a good telecommunications infrastructure nationally, and that limits to a great deal the use of the cloud, which is why the hybrid environments continue to be functional in our country. There are countries in Europe, in Asia, that have double or triple the bandwidth we have, and that's why the adoption of the cloud has been easier and simpler and less complicated than it would be for us. Here, we can have an infinity of applications that are ready to use for the 2,500 municipalities in the country, but the lack of the necessary infrastructure to be able to access this information becomes a limitation that is fundamental in terms of development. So, in conclusion, from the technological point of view, the platform exists. The technical capabilities exist for you to develop and migrate to the cloud. But there are external factors within the cloud ecosystem that you have to take into consideration, which are security, the workflow, the data workflow, and the telecom and bandwidth, the telecom infrastructure and bandwidth that you're going to need for your applications. Thank you very much. While he finishes setting up, our speaker finishes setting up, please remember to write your name clearly and your email on the question formats, because if we don't have time to answer them at the end, our speakers can send you emails in reply. Thank you. So go ahead, Francisco. Okay, good morning to all of you. My name is Francisco Garrido. My company, GeoWare, is a company that specializes in territorial planning, and we've used a lot of solutions in the cloud. In 15 minutes, I'm going to tell you a complete cycle of how we do this. The first thing is, according to Gartner in 2014, there are going to be 66 million users who use solutions, not just Messenger, etc., but we're also going to be using solutions as complex as geographic solutions or the constructive or BEAM, where we're going to see solutions that have increasingly lighter technology that will enable us to consolidate the information. If I were the director of a federal institution or state institution or even a municipal one, I would be facing some of the problems that are most common that we have, because the distribution of IT services, it depends on the geographic point. How do I take technology to different places? And on the other hand, the loss of control in the IT standardization and the legal framework and the infrastructure. Very often we install servers locally, and then everybody changes the structures. there's only one law, but everybody enforces the law depending on the system, so this creates very serious problems. There are many data models and formats that exist, that those who are in IT start facing that everybody has a data model or distorts the model or changes aspects of it. And obviously this is going to have a very expensive consequence when we try to connect the information. So this is a typical problem that we're faced with. We have problems with the consolidation of the data, multi-purpose data. How do I move, for instance, the urban development plans are made on scale X, and then the cadastres or land registries are on another scale. So how do we do it? So something is in the Persian Gulf. So everything is a mess. So we have that sort of problem. The loss of the quality of the data. Sometimes the content is more expensive than the technology. Those of you who do this, cartometry, etc., you know how expensive it is. But if you cannot consolidate them and store them and structure them adequately, it's going to have a super high cost because you can lose all of the investment at a certain point. So the complication for analyzing the data and the generation of indicators online. This is very important. Sometimes they're isolated. The agency starts having islands. They don't share their data. So how do I generate public policies if I don't have the information available? So they do it with Excel or little graphs. And then the difficulty for establishing cooperation and linking be interinstitutional. So how can we collaborate if people don't want to? How can we implement a comprehensive system? So how does technology start solving, and especially these IT cloud computing architecture, how does it provide solutions? Well, it's through a data center. I start, like in the old times with the mainframes, I start having a unified model of datas and multipurpose systems. Instead of each one having their data model at the state, municipality, or district level, and everybody inputs the data, I have a single model, and I define clearly who is going to update what, who's going to say the mapping or the geometry, who's going to updating, well, the cadastre, who's going to be the owner, well, the public registry of property, who's going to update urban development plans. So in a single data model, I grow that and I standardize it. Of course, at this site, I consolidate the data. And this means that there's going to be a transactional change. We'll see that further on. So one administration ends and then it takes all the data. But if I have a single site, then the data stays there and they don't leave. And I can operate them through remotely through the cloud. The unified technological platform, because that's another problem. Each agency has its own database, its hardware, and then that's another problem. Whether there's open database, standardization, it's still a problem. The speed with which agencies are buying all sorts of other products. The distribution of the IT services with any sort of equipment, whether it's desktop or mobile, the cloud solves that. It doesn't matter what your operating system, it doesn't matter if you're on a Mac or a Pentium that you were going to throw out into the garbage. Now you can just go online and you have a computer center that's working. The exponentiality in the capture, the massive capture of multipurpose data, when you standardize the information, mobile devices, if there's a disaster, you can take a photo, it's encoded, and then you can know exactly where it is. So we have this broad view of a unified platform in that sense. The aspect that has to do with the integration of thematic coverture, there's so much information on the internet, terabytes and gigabytes that's standardized, and that's the point, the standardization. And how can I bring it through web services and web map services? How can I bring it in a natural way? So this is the main frame. The security in data storage and data management, those who generate the information, how are we going to construct the information and not just how we're going to query it? So that's important too. And once this is standardized, the ease of collaboration and updating and operation and publishing the information is much easier if between institutions. The online thematic analysis of data that executives and directors can do, well, they can do that now on their iPad and their iPhone. The high availability of IT services, well, the fact that now for instance, there's a data center and a hurricane destroys it, but we have a cluster or a mirror somewhere where that information is there. So we have these sorts of features. We also talk about the elasticity. In other words, for instance, the cadastre or land registry in the first 3 months of the year may need a lot of terminals so that I can go to different districts or commercial centers. So then I open the key and all of a sudden I can just broaden it without having to do not much, or I can reduce it when it's not being used and I'm only going to pay for that, for the actual use. So very generally speaking, I wanted to show you, this is a general architecture. We have a site where the data servers and applications and web servers are put together. Then we can have a cluster somewhere else with high availability. And in the center, we have the unified data model so that we can start releasing the different systems as they become integrated. And that's where we have the big data. It's there naturally, organically. The telecommunications, on one side I have a service provider, and then I have another service provider, and all of those are architectures of how they're designed. That's where we really support that part. At the bottom, what you can see, how you release the applications for cadastres, for a public registry, for water, etc. And you do this in a unified way. You create a comprehensive geospatial collaboration center. On the left, you can consume the information that the citizens are giving you, or the mobile information, and you integrate it organically, and they're going to be feeding you. And on the right, we also have the collaboration with financial systems, REMs, or data mining, even things that have to do with smart cities, and we're starting to grow all of these aspects. And at the top, we have the people that we have to provide the information in a very natural and simple way. To exemplify this, I'm going to show you a small 3-minute video so that you can see what we're talking about. So let me make this bigger. Let me enlarge this, and I'm going to play. So imagine at a government or institution, what we have is that perhaps you're going to go into a land registry or cadastre or the office, and through a portal you go into any equipment in anywhere, and from there you're going to go into a series of services that could be treasury, cadastre, whatever. So let's see what you see. This is the virtualization of geographic applications. From the data center, we can virtualize the geographic applications, and that used to be the problem because there were very dense images. So then we go into an application that we've all seen, like AutoCAD, but now operating from the cloud. So you call a region, you call up a region, you call up the mapping, you locate the vertices or the vectors, and then everything that you do, so then we have that. The technician does the digitalization. The system will generate the code or the key. It will have a control over the key depending on the standards of the INEGI, for instance, or in terms of addresses, etc. And so you have created the geometry. The system can say, wait a second, isn't that superimposed with land uses? Is it on a social property? Is the frontispiece the correct one? Everything that you want. Then after that, the birth certificate. And the birth certificate is the one that's going to go with that property all throughout its life cycle. So these are the famous cadastre forms that have to be filled out. So a technician who maybe is 40 blocks away is doing the cartographic integration. He's doing this organically in a virtual environment on any equipment, and he's carrying out the integration process of the information and creating the geometry and the associated data. Of course, always following the rules and the standards that are established. And then we're going to see how this affects its impact on the final part of the creation scheme. Of course, these environments have all of the capacity that we can see. For instance, here, it's generating the cell, the information, no, the card, rather, the information card. You can associate photographs or files, maps, to that geometry having to do with that particular property. And this is what's common between all of the different agencies so that they can access. Undoubtedly, the engineering part of it, well, that's covered. You didn't have to install anything on your computer equipment. Now, what happens if this user 20 blocks away goes to the Treasury and says, oh, wait a second, I want to pay my real estate taxes? Well, he goes into the application. He asks for Arturo Gonzalez, who has just been registered maybe 10 minutes ago. He's already in the database, and he will be able to pay for his real estate taxes. So two areas are collaborating in different places on the same database, and there's one data center, and this is what enables the collaboration to exist in this respect. In other words, this is something very important. And for people that at the top, you can give them a sphere that they're not afraid of, and they can ask for Arturo Gonzalez, maybe in the public registry of property. They find him on the database. And here we have the famous birth certificate. I can look at it. I'm no longer in the technical area, and now I'm with the users, the people who are going to exploit this information organically, and with all of the technical issues that you want. But you can analyze the information, and this is the process. If I was the public registry of property, I identify that this geometry has the electronic folio X, and I can associate that with it. And even if I didn't have a system, I can associate it with a deed, and there's a data bank for civil protection so that we can have all of the information concentrated, and then I integrate the aspects that have to do with water, and then I can look for it not just of the cadastre code, but also through the water registry, and I should have the same information. And even the part of the information that we would already have to be able to integrate all of the information in a consolidated manner. We were looking at hurricanes before. What happens? Let's say there's a road. If I want to go in the planning stages, I say, well, who am I going to affect 15 meters from this axis? And if it costs 200,000 pesos according to every square meter, so I can read this with GPS equipment, or I can draw it, and the system will give me the information, the owner, the total area, the affected area, how much it needs to be paid. It gives me the total amount. You have to pay 26 million, and I can visualize it, of course. So we're already seeing how you start. Had it been a flood polygon, then you have the information very quickly and organically, including technical information. But we see that someone who created the property, we see that it's affecting Arturo Gonzalez's property, somebody. So all of the analytical part of the information through the business intelligence space, oh wait, generate, tell me how, by color of how the capturing is going per district, per municipality, so we can operate very easily in any kind of distribution that we want. We're exploiting the information, and that's part of the objective, to massify the information and standardize all of these features. So we have, for instance, This municipality, 4 decades of analyses in the health sector, 70s, 80s, and the 2000s. This represents the number of hospital infrastructure in the 70s. It goes down in the 80s, and it grows a little bit in the 90s. If we turn it around now, it can tell me, for instance, it can represent the people with diabetes in the 70s, which wasn't very high, and then it soared in the 90s, and it went down. It dropped significantly. And the radius represents the cardiovascular illnesses because people were eating a lot of lard perhaps at the time, so that was a problem. So you give it elements, but everybody is playing with a single database and a single standardization. So the different institutions and agencies use these sorts of technologies. It's not just querying, but how we were building it. That's important. How we start creating all of all of these aspects. The other aspect, well, obviously, you have the digitalized cities. You can see the building, etc. Well, with the work that's being done, the works you can see, you can give a skin to each of these structures. And you have these very versatile, very quick applications, an infinity of applications. The other scheme has to do with that you could interface with through web services. Let's see now how in good measure we look up Arturo Gonzalez, looking up other services that you've seen on the mobile devices, but now looking at this database, and we look up Arturo Gonzalez, he gives us the point, and we say, I want to go to the hospital X, what's the shortest route? But we are already integrating everything, notice that, so that you can really maximize all the information. And in this sense, it gives you this scheme, and you agree that if I put GPS, then I have tracking, I have monitoring, and so developments become easier, and that's very important. So in conclusion of this presentation, because of my time limitations, I will just show you this last scheme where basically what we're going to be seeing here is the big data, or the large amount of information that we have, how we have tools to analyze through maps and graphs and statistics that same information. This is cadastre type information where in those 6 districts, they're the ones that owe the most. It had 100 million in 6 districts, and in 6 colonies, 80% of this is concentrated, about 80 million pesos, 82 million pesos. We can see that quickly, and we can see that it belongs to 1,200 taxpayers, some of which were public buildings, but 700 were individual taxpayers. So the system tells you, okay, well, where they are, in what districts, where they live, and you can start making decisions. So we saw in very quickly how we went from the data to the exploitation or the construction of the data. We talk a lot about data exploitation, but here you can see through a technology that you use that's both desktop and virtual, that operates with databases that are open source and powerful technologies like Autodesk Mac. You can see the personalization or customization of all these sorts of applications. Finally, to conclude, I'm going to say what are the conclusions of some of the benefits. Well, here we see that it consolidates the information online from a single repository of multipurpose data. That's very important. It's obviously standardized. And then the IT administration from a single site. You don't have to go install in each state. I'm controlling everything from one point. obviously the standardization of processes that are according to the legal framework, and this it facilitates the design environment and implementation environment. It's now you can create applications and develop from a single site. You can analyze geospatial data online for the generation of public policies. There's a generation of performance indicators. And there's also all of the green technology aspects. It promotes green technology because you're working from home, so you generate less pollution. Collaboration, interinstitutional collaboration is made easier, and data are shared, and you aren't fighting for the shares. And then it also ensures the continuity of the business. If we standardize, which is what we're trying to do, then we're going to be able to integrate more organically all sorts of things. So the data is there, which nobody's going to take them away. If I finish doing something, they left and they took the computer. No, the data is there, they're kept there, they're stored there. And then there's the mobile aspect, which is a very strong trend. So this is globally a little bit what I wanted to tell you. So thank you very much. Thank you, Bernardo, Alfonso, and Francisco for their presentations. And because we don't want to go over time, if there's just one or two questions, because we have a limited amount of time, but nobody has sent up any questions. If the hostesses could please bring up the questions. And I'm going to ask the panelists, please, to be as short as possible. This is a question from Alejandro Catalan from Icaza, Mexico. If you can comment a little bit on the issue of augmented reality on smartphones and cameras and tablets, because yesterday we were talking a little bit about this, and he's adding his email. Do any one of you have anything to say about augmented reality? Well, one of the slides that I showed that has to do with the street image, there was an image, or it mentioned, of augmented reality. One of our objectives or commitments is that the information can be published through all of the possible channels. So one source of information that is usable through multiple devices, and one of the ones that we're using in terms of augmented reality, perhaps because the Canary Islands is a small area that receives 12 million tourists, it's important to have updated information as to the tourist sites. There are about 60,000 points that we have controlled with alphanumeric information and photography, and that is can be consulted through software that can be. We have published information sources that can be consulted through the WFS, through the LAIA, I think he's saying. I couldn't understand what he was saying. The second question is Carlos Raúl Montaño from the National Water Commission. What are the benefits or most important differences in using a public or a private cloud? Well, on this issue, it turns out that there are organizations that, because of their administration per se, cannot put data in the cloud, either because of security issues or restrictions. So, but having a local cloud enables you to have all of the capabilities of the cloud, but within your intranet. So I can collaborate, I can request information from another area, use it, publish it, make it available or accessible, but within the intranet. So it's not that one is competing with the other, but they complement each other, depending on the type of information that organizations handle. So in a private cloud, everything is still under the control of the organization because it's in situ, it's there. And one of the offices, it's all there, but it has all of the qualities of the cloud and capabilities of the cloud. And in a public cloud, well, there's information that resides outside the organization. Thank you, Alfonso. Okay, well, I only have left to thank you for your time and to thank our presenters for their excellent presentations and to give them a little token of recognition from our organizing committee.